Hello, my dear students. So let's study an important topic in maths, which is lines and angles. So let's talk about different types of angles. As you can see here, we have acute angle which are less than 90 degree or greater than 0 degree are called acute angle that are exactly 90 degree that are right angle. Then we have angle which are greater than 90 degree but less than 180 degree. They are called obtuse angle. We have straight angle which is equal to 180 degree, as you can see here, the structure of a D. Then reflex angle, which is the colored part here. So angle that are greater than 180 degree but less than 360 degree are called reflex angle. Then we have full angle. So you can see a complete circle is becoming here. So this is called full angle, which is equal to 360 degree. And we are going to study about different types of line, which is line, what is ray, what is segment, and next slide. So these are some types of lines, like we have parallel lines. So lines which are equidistant from each other, they are called parallel lines. This is a straight line. Then we have intersecting lines when two lines are cutting or there is a point of intersection here. This is called curved line, and this is a perpendicular line. Now let's talk about what is a line. So line is one-dimensional and can vary in width, direction, and length. Lines can be horizontal, it could be vertical or diagonal, straight or curved, thick or thin. And as you can see, it can extend in both the directions and it has no endpoint. So you can see here in the image, like we have two arrows, that is, it can extend in both the directions and it can be denoted like this. So a line can extend infinitely in both the directions, and this can be denoted as, like here we have a line CX, so it can be denoted as CX with a double arrow headed structure. Now, what is a line segment? A line segment is bounded by two distinct points on a line. So we can say it is a part of a line but with two distinct endpoints. Or we can say a line segment that is a part of a line that connects two points. So here we have CG as a line segment, then we have GR, another line segment of 5 units, then we have RX, which is another line segment of 3 units. Now, a line has no endpoints, but a line segment has two endpoints, or we can say it has two fixed or definite endpoints. Now, what is a ray? A ray is again a part of a line having one fixed point, as you can see in this image, like BA is a ray, so here B is the endpoint and it can extend in one direction with an arrow here, and it can be denoted as BA with an arrowhead. It means that a ray has one terminating end, so here B is the terminating end and the other end is extending infinitely. Now let's talk about a transversal. Now what is a transversal? A line that intersects two lines at distinct points. It is called a transversal. For example, in this image we have line L. This is line L. So this intersects line M and line N at two distinct points P and Q. So we can say the line L is the transversal line because it is intersecting line M and line N. So in other words, a transversal is a line that's cutting across another lines, and it basically creates 8 different type of angles. Now we will discuss more about 8 different types of angles. They are corresponding angles, alternate interior angles, alternate exterior angles, and they are supplementary angles, as you can see in this image. So let's talk about these type of angles one by one, and let's talk about an angle formed by the transversal and the two parallel lines. Now AZU. So let's talk about this angle. So AZ and ZU are the two arms of an angle, and any line cutting across parallel lines could be termed as a transversal, which we discussed in previous slide. So here you can see the green angles are called as the interior angles, and the angles which are colored with blue, they are the exterior angles. So angle 1, angle 2, angle 7 and angle 8, they are called exterior angles, and angle 3, angle 4, angle 5 and angle 6, they are interior angles. And as we know that this is your transversal, as it is cutting these two parallel lines. Now let's talk about one of the pair of angles called corresponding angles. So you can see in this image like angle 6 is corresponding to angle 2. So this is your angle 6, it is corresponding to angle 2. And angle 1 is corresponding to angle 5. So here is your angle 1, it is corresponding to angle 5. Then angle 3 is corresponding to angle 7. So here is your angle 3. It is corresponding to angle 7, which is here. Similarly, angle 4 is corresponding to angle 8, which is here. Now let's talk about alternate interior angles. As you can see, two congruent angles from different parallel lines. Let's say we have angle LAR, which is your angle LAR, that is this angle, which is equal to angle ARN, which is angle ARN, that is this angle. So basically you can see in this image like angle 3 and angle 6. These two are alternate interior angles. This is another pair of alternate interior angle, which is angle 4 and angle 5, colored with pink color here. And these are the two lines, parallel lines. So any angle that is formed between the two parallel line and a transversal line, they are called as alternate interior angles. Now let's talk about alternate exterior angles. So let's say the angle which is colored with blue here, that is angle 1, is equal to angle 8. So they are alternate exterior angles which are opposite side of the transversal. And angle 2 is equal to angle 7. This is again another pair of alternate exterior angle, as they are one another side of the transversal line. So as the theorem says, if a pair of parallel lines are cut by a transversal, then the alternate exterior angles are congruent. So we can see in this image like angle 1 is congruent to angle 8. So means angle 1 is equal to angle 8. So they are congruent. Here these are the two parallel lines and it is cut by a transversal line. So angle 2 is congruent to angle 7. As we can see, this angle is equal to this angle 7. Now let's talk about vertically opposite angles which are equal. So whenever we have two intersecting lines like PQ and RS, so these are the two intersecting lines. So you can see the vertically opposite angles here, angle M and angle N. So they are vertically opposite angles sharing the common vertex. So similarly, angle A will be equals to angle B. They are also vertically opposite angles. Similarly, same side exterior angles are always supplementary. It means when we add these two angles, you will get the sum as 180 degree. So for example, this angle, that is the same side of the exterior angle, will be added to this angle and the measure will be equals to 180 degree. So these are the same side of exterior angles which are supplementary to each other. Similarly, when this angle would be added to this angle, they are also same side of the exterior angle, so they will be their sum will be equals to 180 degree. Now same side of interior angles are always supplementary, so here you can see that angle 1 and angle 2, they are same side of the transversal, which is this line. So angle 1 plus angle 2 will be equals to 180 degree. As we have already discussed in the previous slide, what are corresponding angles? As you can see that this angle A will be equals to this angle. These both are equal. Similarly, this angle will be equals to this angle, or we can just mark it with double lines. So these two angles. And similarly, let's talk about the another pair of corresponding angles with a highlighter here. So this pair and this pair will be equal to, and then we have this pair, let's say this pair, and this pair of angle will be corresponding to each other, so they'll be equal. And alternate interior angles, as you can see, angle 5 is equals to angle 6. Similarly, angle 7 is equals to angle 8. They are alternate interior angles. And alternate exterior angles are also equal. Angle 1 will be equals to angle 2. Angle 3 will be equals to angle 4. So I hope you get all the different types of lines and angles. So thank you for watching. Have a great learning.